So let's discuss numerical methods in engineering. Okay, so first we'll see why we require numerical methods. Well, complex analytical functions or complex analytical algebraic equations or your, say, if you want to find out the solution for differential equation, then complex differential equations. Okay, well, all sometimes it is difficult to find. For these cases, sometimes it is very difficult to find the solution by analytical methods. For some complex case, even the analytical methods don't exist. So in that sense, one has to resort to numerical methods in finding. Numerical methods are some kind of approximation techniques in order to solve problems in engineering. Okay, and one advantage of numerical method is that they are repetitive in nature, and so you can automate it by a simple program in Fortran or C, and this will avoid any errors, manual errors. Okay, so that is one advantage which repetitive nature of the numerical methods lead to automation. Okay, so in this section we'll see how to apply numerical methods in solving algebraic and trigonometric equations. So transcendental equation, this second case will apply in solving differential equation, and in third we'll apply in finding the integration, doing the integration, finding the integration of some functions. Okay, basically the numerical integration. All your trapezoidal rule or Simpson rule will come here. Okay, so broadly we'll study these three applications of numerical methods. Okay, so let's start with solution of algebraic and transcendental equations. So in this solution of algebraic and transcendental equation, we'll see solution of algebraic and the trigonometric equation, which are called as transcendental equations. Okay, so how to find solutions of this? So we'll see three methods. One is bisection method. Okay, the second is method of false position, and the third is the famous Newton-Raphson method. Okay, so we'll see all this one by one, and so let's start with the bisection method. So this is, let me call this is ABC, the bisection method. So what does this mean? So the general thing here is to find out the roots of the equation, which is, say, of f of x equal to 0 form. So you need to find out the roots of this equation. And so what this method says is, so this method helps in locating the roots of this equation in an interval. Say this a comma b is the interval in which you know that roots are there. Well, how do you know roots are there? If f of a and f of b are of opposite sign, and if generally the functions are continuous. So if the function is continuous and f of a and f of b are opposite sign, then root lies in A and B. This is because if f of A and f of B are opposite sign, so somewhere between A and B, f of x will be 0, and that is nothing but the root. Okay, that is nothing but the root. Okay, so therefore the root belongs to A and B. So what does this method says is, it approximates, it bisects the interval, basically divides the interval into half and takes a value, say x1. So it approximates the root to be basically the at the midway between the end limits, so A and B. Okay, so now I'll evaluate f of x1. Okay, so if I evaluate f of x and it comes out to be 0, then x1 is the root. Otherwise the root lies between A and x1 or x1 and B, depending on whether f of x1 is positive or negative, depending on f of x1 is positive or negative. Okay, I mean, and so that's it. So you have to just use this fact that if the roots are of opposite sign, then if at the intervals the roots are of opposite sign, then the root lies between the intervals. So basically you are bisecting the interval every time, bisecting the interval, reducing the interval into half. Every time you are bisecting the interval into half and then checking for the root. So this is the simplest way how this method works. So let me explain it graphically, then it will be more helpful. So what this method says graphically is that, say if I have x here and y I am plotting here, 0 is the origin. So in this case, say the roots, if the f of x is something of this form, okay, and here I have b here, and here I have a here. Okay, so x1 is a plus b by 2. Okay, so basically from this you can say that f of a, which is y value, is negative, and f of b, which is y value, is positive. So root lies between a and b, that is for sure. That's why here is the root. Now we need to approximate it. So just you will find out x1 as a plus b. So x1 a plus b might be somewhere here. Let's call this as x1. So now f of x1, you know it's positive, so therefore now the root lies between a and x1. So then again you will divide the interval between a and x1 by 2. Okay, and now so it may lie somewhere here, it may lie somewhere here, and this is x2, somewhere here x2. So now you will again check f of h2. So f of h2 is negative. So it means that now the root lies between x1 and h2. Okay, x1 and h2. So now you will make a guess that the approximated root is x1 plus h2 by 2. So on you will check the sign and then just approach towards the root. So now obviously when x3 will be somewhere here, so you are approaching the root. Okay, then again you will check f of x3 and so on. So this is how it's iterative in nature. So let's solve an example in order to describe this. Okay, so find a root of the equation x cube minus 4x plus 9 is equal to 0 using bisection method in 4 stages. Using bisection method in 4 stages. Okay, so that's what. So So here he has not said actually the interval. Generally the interval will be given, or otherwise you need to just see. So let's decide the interval. F of 0 is basically 9. F of 1 is, substituting here, it will be 1 minus 4 plus 9, it will be 6. F of 2 is 2 cube 8 minus 4 to 8 plus 9, which is 9. F of 3 is 3 cube is 27 minus 3 fourths 12. Sorry about this is minus 9 actually. So this is minus 9 0, and this is minus 12, and this is minus 9, and here it is 24. When you substitute, it's equal to 3. This is 12, and this minus 9, so this becomes positive. Okay, so you can say that between the interval 2 comma 3, because f of 2 is negative, f of 3 is positive, so the solution interval, solution interval in the sense somewhere here between 2 and 3 it lies. It's an open interval somewhere. It's not an interval basically. Solution lies between 2 and 3. That's what you know. Okay. So now first stage, we approximate x1 to be 2 plus 3 by 2, which is 5 by 2, 2.5. And now I check f of x1, which is f of 2.5. So this is 2.5 whole cube minus 4 into 2.5 minus 9. So this value comes out to, you can use calculator here, this comes out to be negative. So x1 comes out to be negative, and f of 2 is negative, f of 3 is positive. So now know that root lies between x1 and 6. So that is between 6 and between x1, which is between x1 and 6. Okay, so now let's continue. So basically x1, the root lies between x1, which is 2.5, and 3. It's not 6, 3. Okay, but so between 2.5 and 3. So now the second stage, you have to assume x2, which is x1 plus 3 by 2, which is 2.5 plus 3 by 2, which is 2.75. Now f of x2 is 2.75 whole cube minus 4 into 2.75 minus 9. This comes out to 0.767969, which is positive. So 2.75 is positive, f of 3 is also positive, f of 3 is 6. So now you can say that root lies between 2.5 and 2.75, between x2 and x3. Okay, so now the third stage will be basically x3 is 2.5 plus 2.75 by 2, sorry, this is bisection method. So you will get 2.625. So now f of x3, which is f of 2.625, will give rise to 2.625 whole cube minus 4 into 2.625 minus 9, which is minus 1.4121. This is negative. Okay, so this is negative means the root should lie, because at 2.75 also it was positive. So root lies between 2.65625 and 2.75, because at 2.75 f of 2.75 is positive. So now for the fourth stage, what we do is we assume x4 as, again at the midpoint of 2.625 and 2.75. This becomes 2.6875. okay, this becomes 2.6875. okay, So this is the fourth approximation of the root, and that is basically the fourth stage. So hence the root we'll say is 2.6875 approximately. Okay, so this is how a simple bisection method you can just approach to the root. So this is a very simple method, simple method to find out approximately, more or less, in the desired accuracy you can just find out the root. So this is one of the simplest methods. Now let's discuss the second method, which is method of false position. Method of false position, and sometimes it is called as regular falsi method. Okay, regular falsi method, and this is one of the oldest method to finding a real root of f of x equal to 0. So how this method works is it basically works, choose 2 points. So we are solving f of x equal to 0, we need to find out interval. So choose 2 points x0 and x1 such that f of x0 and f of x1 are of opposite sign. So this is just similar, this step is just similar to are of opposite sign. So this step is just similar to your bisection method. You have to basically find out an interval in which the root lies. That's what you're doing by this method. Okay, such that opposite sign. So what will happen is, what does this mean is that the graph of y 0 f of x will basically cross the x-axis. That is what this method means. Okay, and basically it indicates that the root lies between x0 and x1. So now x0 and x1. Okay, so now what we do is we write now the equation of line joining joining x0 point and x1 point. So basically let me explain with a graph. Okay, so what it means is, say if you have something like this, the root is this is x and this is y. Okay, and you have one point here, say this is x1, and somewhere here you have a point A where is x0. So this is basically x0 into f of x0, and this is nothing but b x1 f of x1 f of x1. So these two are the points. So now what this method says is that join a and b, so I'm not able to draw it correctly on this graph because of slight movement. So let me just try it again. So let me just redraw it. Okay, and say I have 2 points. Okay, joining these. So this is your b, which is x1 f of x1, and this is your a, which is x0 f of x0. Okay, so this is point x0 and this is point x1. Okay, so line joining AB is this way. Okay, this is A, this is B. Okay, so you have the line joining between A and B. Now the equation of this line, okay, I can just, because I know the 2 points, so I can just write down the equation of line, which is y minus y1. So any point I can take A, this thing. Then the slope I can just find out. I know 2 points, so f of x1 minus f of x naught by x1 minus x naught into x minus x naught. Okay, so this is the equation of the line joining AB. Equation of AB. Okay, so now what this method means is, now where does this line cuts x-axis? This cuts x-axis when y is 0. So at that point I can get, just substituting y0, I can get x. So x2, let's call that point to be x2. Okay, the point at where it cuts, let's call h2. So h2 is x naught minus x1 minus x naught by f of x1 minus f of x naught into f of x naught. So this is an important equation. Okay, so this is one approximation of the root x naught. Now you can just check f of x naught. So same thing, now you have to just check f of x naught, f of x2. So these will be of opposite sign, or of opposite signs, because f of x naught is positive, this is y, which is equal to f of x, and this is x. Okay, so obviously f of x naught is positive and f of x2 is negative, because f of x2 is this. Okay, so this is point C. Okay, and so now I repeat the same procedure by writing equation of AC. So I'll just now join the line C. Okay, equation C. So once I join AC, again it will meet somewhere here, right? So basically I'll join AC. So I'm just moving closer to the root, closer to my root. Okay, okay, so the idea here is replacing x1 by x2 in above in the star equation. I can get next approximation x3. So this is the basic equation, approximation x3, and so on. Okay, so until I get the, so this process is repeated until I get the desired accuracy. So let's solve some problems so it will be clear. Okay, it will be clear when I solve this one. So this graph is not there, and you can just follow this graph. So basically you have to you're joining 2 points by equation line, and where it meets the x-axis, that is your x-intercept. Now you have to try between x-intercept and either of these two limits, depending on the sign of f of x2 and f of x1 and f of x1, f of x0 and f of x1 and f of x2, depending on their sign. Now you have to reduce the interval and then again try in the same procedure. So this is just the false position method. Okay, or basically the false position method. So let's now solve one problem to describe this iterative process, and basically we'll be using this equation of line, where x2 is an approximation of the root in the interval x0 and x1. Okay, okay, so find out the real root. So now we have discussed this false position method, so let's solve a problem on this. Find out the real root of x cube minus 2x minus 5 by the false position method, by the false position method. And so false position method, correct to 3 decimal places. So we need to see that the accuracy is met up to 3 decimal places in the interval 2, 3. So he has given the interval. Even if he has not given, then we have to just proceed as we did in the previous example. We have to just proceed just like in the previous example. substituting we have to get. So f of 2 is basically 2 cube minus 2, 2 minus 5, which is 8 minus 4 minus 5, this is minus 1. And f of 3 is 3 cube minus 6 minus 5, which is 16. So it lies between the roots, that's what you know. Okay, so x naught is 2, f of x naught is minus 1. Okay, x1 is 3 and f of x1 is 16. So that's what you know. So now let's approximate the root by that formula. Okay, so the physical interpretation of what we are doing is whatever I have shown you just before solving this example. Now as far as the example is concerned, you have just apply this formula iteratively. Okay, so this comes out to be 2 minus 3 minus 2 by 16 plus 1 minus 1. So this comes out to be 2 plus 1 by 16, which is 2.0588. Okay, now f of x2, which is f of 2.0588. Okay, this value, so this value is minus 0.3908. So we can say that root lies between, because this is negative and this is positive. Okay, so you can say that root lies between 2.0588 and 3. So similarly you have to repeat for the next root. Okay, so you have to just carry on the same process. Okay, so if I now what you have to do is, this is, so 2.08 becomes your x naught and this becomes your x1. So you have to just substitute it in this expression, in the general expression. X naught is 2, x1, so you will get, yeah, you will get x2, which is nothing but x3, general approximation. So this will be 2.0813. Similarly, if I just check this and evaluate everything, so I'm just listing out all this, 2.0862, then x5 will be, so this is your x0, this is x1, when you substitute it you will get 2.0813. Now for 2.0813 I have to check the f of x2, and based on that, so if we just repeat the process iteratively, I get these values. You can just check with the help of a calculator, you can just try all this. So now you can see that root is, you can, by this you can say that, because it is just changing in the fourth digit. Okay, it's not changing in the third digit, so till third digit is constant. So root is 2.903, correct to 3 decimal places. So that's what I mean, till 3 decimal places you are sure that it is 2.094, and then the fourth digit you are not sure, it can be anything. Well, if you solve more and more, you will get more points. Okay, so this is how the method of false position works. Basically you have to just fix x0 and x1 such that f of x0 and f of x1 are of opposite side, and then you have to just evaluate this based on this. So this is basically an approximation of the root, okay, based on x0 and x1. So you have to always, so this I have just done it, and you can also do it. So first step I have done it, and then you have to just do it and find out the roots. Okay, generally this much is not asked. I mean, if it is a gate question, they will just ask you in couple of steps, only 2 stages or 3 stages, and probably correct to 2 decimal places rather than 3, because 3 will take time. So we have seen bisection method, because bisection method sometimes may take more time. You are basically bisecting the thing. Okay, but here in this false position method, you are drawing a chord, and then where it intersects you are seeing. Okay, so this normally will not involve more time. Okay, this will be faster. The convergence will be convergence to the root. Convergence means the approach, the fastness with which you are approaching to the root will be fast here. I mean, the way you are approaching the root will be fast here. Whereas in bisection method, it's a old, the primitive method, so it's just bisecting the interval half and half into half every time. So that's the difference. So now let's see another method called Newton reaptation.